Our second option for atomization is what's known as a furnace. This isn't like the furnace in your house, but it is a place where some stuff gets really hot. And so this is what these furnaces look like. It's a pyro-coated graphite tube family. This is one specific kind. You can use other ones, but it's this tube. Your sample goes in this hole here. So this is for sample injection. And then you close it up. And the idea is you then electrically heat. You use electrical heating to heat this entire metal tube up, or graphite in this case, not metal. All right, and so your sample goes inside, and yeah, so I said metal, but these are actually made out of graphite. Graphite has a high resistance, so you pass a lot of electric current through it, and it heats up. And then you have, on the ends of it here, you have windows to let your light come in. So, if we sort of picture this in terms of putting it into a spectrometer, we have our hole on the top. We place our sample in here. So we'll have like a drop of our solution on the bottom here. And then we heat it up to something like 2100 degrees Celsius or something like that. And we'll have our light from our hollow cathode lamp that comes through while this is at the high temperature, and we measure how much of it gets absorbed. So we don't have an actual flame happening here, but we do get, all of our sample gets burned up. What's the point in doing something like this? One of the advantages this has over flame is that there's no flame, right? So more consistent heating is the way I put it. So it's a lot easier to control the electric current going through something than it is to control a flame, right? We do our best to try and get the flame as consistent as possible, but you can't always do that. That leads us to have better sensitivity. So in general, furnaces will give you better sensitivity than a flame atomization will. And one other advantage is that you need less sample. So with a flame, the sample is continuously being consumed as the flame is burning. If you have plenty of sample, that's not a big deal. But say you're measuring something where you can only get a little bit of it at a time. With the furnace, you just put in the sample you have. Once it's burned up, once it's hot, it stays there inside of your furnace, and you're able to measure it directly. It stays in the light path for longer instead of just burning and leaving as it does with a flame. And so when you use a furnace, you don't just heat it, I say you just heat it up. You don't just heat it up. There's usually a multi-step process in doing the furnace. So just as an example of what this might look like. So this is an example heating sequence. We might first dry our sample. Put this at 125 degrees Celsius, just above the boiling temperature water, and maybe do this for 20 seconds just to get any water out of the system. Then we do a charring step. The idea here is that we want to get rid of any organic material. And the problem with that is that when you burn organic things, you make smoke. And obviously smoke is not good when you're trying to measure absorption, because the smoke will scatter the light that's coming in from the hollow cathode lamp. And so it'll look like you have absorption when you don't actually have absorption. So you want to let the smoke happen and then get out of your furnace. All right, so that would happen at, say, 1400 degrees Celsius, and we do this for like a whole minute to give it long enough for everything to burn, the smoke to be generated, and then to leave. And then we actually do our measurement here by atomizing at 2100 degrees Celsius for 10 seconds. And this is where we do our measurement. And then finally, to prepare for the next sample, we do a cleaning routine at even higher temperature to try and burn any residual matter up, and do this for 3 minutes. And this is to prepare for the next sample. One other advantage of a furnace is that we can use solid samples directly. So you can put a solid sample directly into the furnace, whereas with the typical flame spectrometer, there's not really a way to inject samples, and you sort of need to dissolve it first before you can put it in. But with the furnace, you can, so that's another advantage. You can use solid samples directly. Okay, so that's it for furnaces. In the next video, we'll look at our final atomization technique, which is the inductively coupled plasma.